Power. In our first 250,000 years, human technology went largely unchanged. But in the last 2 centuries, we have transformed our world. Once humanity was able to harness resources previously hidden throughout the planet and create planes, trains, automobiles, and electrified homes and businesses, our world changed dramatically. And now we're beginning to pay the price for all the technological marvels this energy has given us. At the Science Museum of Virginia in Richmond, visitors can't miss this large video wall that demonstrates just how critical our decisions and our technological development will be in the next generation.
This wall draws attention to energy use, energy demand, and world population. It takes it from a global scale to a national scale to a state of Virginia scale and makes people think about the energy that they're using and where it comes from. 9% of energy produced worldwide is from alternative sources, including hydroelectric, which is the greatest contributor to that category. 91% is fossil fuel and sources that contribute CO2 to the atmosphere.
The United States has a less than 5% share of the world's population, yet we use 20% of the world's energy resources. And most of what we use are the fastest, cheapest, and most available sources of energy: gas, oil, coal, and nuclear power. All 4 have significant drawbacks. 3 are predicted to run dry within the next century. All 4 produce toxic waste that's harmful to the environment.
Some of the non-renewables, ultimately we're going to run out of them. So that's one issue. A second issue is a lot of the non-renewables have their own issues. For example, when we burn fossil fuels, we produce carbon dioxide, and many believe that carbon dioxide leads to the greenhouse effect and the warming of the earth. And so that's a challenge. Nuclear is sometimes considered renewable because it doesn't use much fuel out of the ground, and that fuel can be reprocessed. But of course, we've seen lately there can be concerns with nuclear as well. Nuclear is not going away, it's very important, but I think for our communities, we need a balance of all these systems, and increasing the amount of renewable energy that we're using can help reduce our dependence on other countries for importing oil. It can help with the environment, with less burning of materials, and we won't run out of it.
Over the last generation, scientists and engineers have crafted alternatives to these forms of energy. These innovations have put us in a position to change course. Wind power, hydroelectricity, biomass, solar, and geothermal power are all beginning to create energy for home and commercial use. Right now, all of these non-polluting and renewable resources make up about 9% of the energy we use. It's a start. Today, the typical cost of electricity for conventional sources is about 10 cents per kilowatt hour. Currently, renewable energy costs more.
As the price comes down on wind and water and solar, we're going to approach the time within a decade or so that the 10 cents a kilowatt hour retail cost to the individual residents, that alternative energy systems will break that barrier.
The Science Museum illustrates what this reality can look like with a model home powered by alternative forms of energy. Solar panels pull in energy to run all the appliances, and a geothermal well does all the work coal and oil used to do.
The geothermal well is connected to 2 geothermal heat pumps. Generally speaking, a residential geothermal system is next to domestic hot water. The geothermal system is the most likely system to repay the investment within 5 years. It takes heat from the ground in the wintertime and puts heat into the ground in the summertime. If you can imagine, you've got a coil outside your back door somewhere in the back of the house that tries to take 130-degree coolant fluid and cool it using 90-degree ambient air. Instead, imagine using 60-degree water. That's the advantage of geothermal. Once you go more than 30 feet or so into the earth, the average temperature underground is equal to your average annual temperature night and day for a year.
Another of these alternative energy sources creates a significant change of something so purely American, the automobile. An abundance of fuel over the last 120 years filled up gas tanks and transformed us into a traveling nation. The convenience and economic benefits have been nothing short of transformative. And while we love our cars, we have to make changes before the fossil fuels run dry and the air and water pollution becomes unbearable. The Science Museum hosts an electric car charging station where owners can come in and fill up, if you will. This technology is fascinating, and once the investment is made, can ensure drivers can travel at a fraction of the cost. Battery limitations have prevented electric cars from becoming abundant, but that may all soon change as today's generation of students become adults and begin their own efforts to create change.
If you're going to build a large hydroelectric dam, you need the right geography. And I think in the U.S. we've pretty much used up all that geography.
And that's where teachers and the GreenSTEM at VCU program come in. While our generation has ushered in the idea of renewable and non-polluting alternatives to meet our energy needs, it's going to take the next generation, today's students, to help humanity take that leap and create nearly limitless clean energy to power our world. At the VCU School of Engineering in Richmond, middle school teachers are preparing to show students how it all works by creating alternative energy experiments that will help students see what is possible. Today, it's everything from solar cells to solar water heaters to mini hydroelectric power generators made of plastic jugs, spoons, cork, and copper wire.
Believe it or not, you're going to make a solar cell using blackberry juice.
You have to take one of these. One of these goes in the blackberry.
After a couple of hours of cutting, gluing, and measuring, teachers shared a moment they know their students will love. They created their own clean power.
It did go back up.
Are you generating power?
Yes.
We are generating
And
power?
what we did is because we saw it going down, so we added more of the iodine to see what effect it truly had, and it's going right back up.
Okay, I'm holding my breath. Unbelievable.
Want to go faster?
What is this going to do for students when they can create something like this?
They'd be on cloud nine.
Definitely.
They'd really feel like they could do something.
That they actually can construct something that would, and see it on a bigger scale.
So you're excited that you did this, but aren't you also excited because of a new tool that you have in your
Yes,
Yeah,
definitely.
absolutely.
We're concerned about X-Acto knives with middle schoolers, but we'll have to just get around that.
There's so many aspects of it that they can participate in, which is great. That's what's good about a good lab. Everyone has something to do.
These teachers see how they can show their students the connection between science, technology, engineering, and mathematics. They also see how they can show students the world of opportunities that exist in creating green technologies.
It provides opportunities for both engineering and science. So there are, science is isolating variables, making observations, and engineering is looking for solutions. And it gives both those students who are oriented to the science and the student who's oriented to engineering opportunities for discovery here. These experiments and problem-solving opportunities really help kids see themselves in solving bigger problems, and that's what the green industry is all about. It's solving big problems. Kids who are naturally drawn to service learning really get a kick out of that and a charge out of that, and hopefully they tell their parents about it, and then the parents and counselors and teachers start guiding them through those college selection processes with that in mind, and sooner or later we see them in university settings like this and taking the next steps in that exploration.
The future of alternative energy is full of possibilities. We need new ideas and people with enhanced skill levels to get us where we are far less dependent on fossil fuels. These teachers working in the GreenSTEM at VCU program are preparing the next generation of students to be the generation that seeks out and finds solutions.